Welcome to this short video. It's going to be whizzing through the Monster Section C questions, and for your delight I'll be giving you the official answers. I thought I'd do this as a video rather than just a mark scheme, because that way I can explain a bit of the terminology, as it's all going to be OOP. So let's whiz down. List all the identifiers of classes in the Monster Skeleton code. Well, if you don't know what a class is by now, you might be in trouble. So what I did was just whiz to the code. Let's move this up a bit and hide everything, and you can see 1, 2, 3, 4, 5, 6 classes. And I said I just want the identifiers, so really you should just give the names, which are there. Right. Now give an example of instantiation. I think this is all of them. So I'm just going to move my, sorry for the scrape, I'm just moving my tablet a bit closer. All of these are instances of an object being created from a class. We're not just putting the space in memory for it, we are actually instantiating the class because we're using the new keyword. One of the things that Phil and I do as a little cheat when we're looking at your coursework is, if we want to know, how well have you been using an object model, we look for that new keyword. If it's all over the place, then that gives us a bit of confidence that you're actually instantiating your classes and not just using them as blocks for code. So you can see here, most of them are actually in the game class, but there's also the one in the main program. In fact, there's two, isn't there? Of course, it declares my game as a new instance of game with false, being set as the parameter, and the other one, if it is a training game, instantiates my game with as a new game with true as the parameter. So I could have actually put another one in there as well. Right, list all the methods from the game class that will return one or more values. You've just got to search for these. So it's a method, it's in the game class, it returns one or more values, i.e. it's probably a function. I suppose it could be a parameter that's passing back by ref, but really if you see the word return, it means a function. So let's have a little look. Open up the game class, and we've got get move, check valid move, returns a boolean. This returns cell reference, so that is obviously an object that's holding more than one value, so that's fair enough. And we've also got get random position, so those are the ones you've got to shove in. As always, we're being careful to just give the identifiers unless it's being actually asked for a bit of code. Right, state the name of an identifier for a class that uses composition. Well, I've just given it away, haven't I? There is only one class that is a composition of other classes, or one object that's a composition of other objects, and that's the game class. The only other example of composition was in the submain, and that's not a class. So that's pretty easy. State the name of an identifier. Let's move this across. State the name of an identifier for a local variable that's used to store a Boolean value. Well, this is not even OOP now. You could. All I would do for this is whiz through to the code, and personally I would go Control F, so that I'm looking to search Bosch, and we can see that there are whole bunch of examples of this, and you just got to look for one that's a local. I wouldn't call a private property of a class local. It's not. I wouldn't call a parameter local. However, I'm within a nice little procedure here or method, and I've got 3 booleans all sitting declared with local scope. So they're prime candidates for it. Actually, looking at it, these 3 are the only 3. Valid move does appear in another procedure somewhere, but right, so we're now on to F. List all the identifiers of the objects, examples of compositional aggregation from the skeleton program. Well, that's a little bit like, where are we? Give an identifier for a class uses composition, and as it happens, it's also very, very, very similar to this, because this list here happened to be the list of classes that are being instantiated within the game class, so they are also the examples of compositional aggregation. However, this is wrong. This is nil point, because it just wants the identifiers for the objects. So we just want that list there. So give me 2 seconds to work some magic. So these are the identifiers, and that's the right answer. Obviously, I just want all of them actually for this. For 1 mark, it's a bit harsh. Right, we're going to go through to H because that's all I asked you to do for the first half. So we've got 2 more to go. Look at the place of routine and in the game class and explain the conditions that must be met for the loop that ends on the last line of this method to be exited. Right, you need to read that sentence about 3 times, but this is what it meant. Go to play, and you can see that we've got a variety of loops. Got a tiny little loop here, we're going to ignore that, bosh. We've now got another little loop here, bosh. But this is the one we're after, because it says loop that ends on the last line of this method. Okay, so this ends on the last line of the method, and it's saying what are the conditions for this loop to be exited? Well, loop until eaten or flask found or move direction. So if I hover over this, that's a boolean, and this is a char. So it's move direction equals n, or flask found is set to true. We're not saying it's explicitly equals to true because you don't need to because it's a boolean, or eaten is true. So it's any one of those 3 statements is true. And do you know what? I think I'll just do this. But what we've got to say is go equals true or ter. Now really, it does say explain, so really you ought to say that somewhere in the loop eaten is set to true, or flask found set to true, or move direction holds the value m. But I'm just going to leave it like this. Right, the last one for tonight. List all the identifiers for all the constants in the skeleton. Oh, it's an easy one to finish. Just the constants, and then it's 4 marks. Then give the benefits of using constants over numerical values. This one comes up quite a bit, because I want to say about why not just have a variable that's initialized with a value. So first of all, chuck into here, and let's flick through it. 1, 2, that's the lot. So thankfully there's only 2, and it just wanted the identifiers, I think. Yep. So it's just NS and WE. Where are we? NSWE, and those are the two identifiers. For Y, let's have a think. What's the benefit of using constants over numerical values? Well, you only have to change it. You've got one place you can change it, and that change will be propagated throughout the code wherever the constant is used. That's a key one. Another one is that, of course, a constant is very, very obvious. It's readable. So actually, is NS and WE not particularly, but it's not bad. If you know if you work it out, one's not the grid position north south, the other one is the grid position west to east. And why not just use it as a variable initialized with a value? Well, constants are immutable. That means they cannot be changed. So nobody else in your code, or no one else who's writing in your code, and nowhere accidentally can you overwrite that value and actually change. That's a grid position, grid size, of course. Can change those values accidentally. Once they're set, whatever the value is at the start of runtime, that's it, they stay at that. So those are probably your key points. And I think that's a lot for this first half. I wanted to keep these fairly short and sweet. I will do I through to whatever we ended up going to as a separate video. Hope you found that useful, and I hope you're starting to get your head around all of the OOP terminology.